Okay, let's go ahead and get started with exponential and trig limits. So for exponential graphs, what we have here is we're going to start off by looking at the graph, and then we're going to have to be able to actually graph the function without it being given to us. Okay, so what we're going to look at here is it talks about f of x equals 3 halves x minus 1 minus 3. So things that we should know as soon as we see that are that minus 3 is our horizontal asymptote, and that 3 halves means that it's growth. Okay, so when a is greater than 1, it's growth. For this one, we'll say when a is less than 1, we have decay. All right? Now, this one right here is still our horizontal asymptote. And then we'll go through and we'll do the limits for these two functions. Now, when we're actually graphing these ourselves, we don't actually need to have perfect ordered pairs on there. We're just looking for the general shape. Because as you notice, most of our questions are just asking about infinity. When they're asking about infinities, you get to know just where is it headed to when I get further out. Okay? So when we look here, this is an ask for letter A says the limit as x approaches negative infinity. That's to the left. So if I look to the left, this one is headed toward its asymptote, which is at negative 3. Okay? Now, when it asks you about positive infinity, you have to trace to the right, and it looks like it's going up towards positive infinity. If you just write infinity there, that's fine. I just like to be super specific. Now, if we look at the other one, negative infinity. So if I look to the left, this one is going up to positive infinity. And then if I look to the right, that's what positive infinity means here. We're headed towards our asymptote. All right? Now remember, when we're given a graph, this is pretty easy because you just look at it. But when you have to graph it yourself, it gets a little bit more difficult. So now again, we have our horizontal asymptote at 2. All right. Oh, I forgot. Let me see if I can make it. Oh, there we go. That's much easier. Okay. So one thing that we do need to know is that this right here gives us a vertical flip. So in front, we talk about vertical flips. Whereas if there was a negative here, so if negative x, then there would be a horizontal flip. Okay? Now we don't have that here, but that's just if that were to happen. Okay? So now it says, so notice ours was growth. P means growth. Which is 2.7. Growth. Okay, so it was growing and then it flipped upside down. So that's what we have a picture of here. Okay? So as we head towards negative infinity, that's to the left, we're headed to the asymptote of 2. As we approach positive infinity, it's going down. So we'll put negative infinity. So as we go to the right, it's going down. Now for the next one, I'm not going to label everything since we've been talking about it, but it says negative infinity. So as I move to the left, this one is going to negative infinity. And as I move to the right, this one's going towards the asymptote, which is 2. Okay? All right. Whoops. Now let's go to the next page. So this time you have to graph it yourself. So you have the option of just graphing the final version, or you can go through and you can actually show all of the flips and all of that. So I usually just show them all. So what I'm going to say is that pink is the original. And then I'm going to go with blue is the final. Okay? So any colors in between are just going to be shifts that I need to make. So plus 2 is going to be our horizontal asymptote. So I'll draw it there. And then we have that this one is growth. Or I'm sorry, this one is decay because it's less than 1. And then this one tells us we have a vertical flip. Okay, so I'm going to draw the original one. It says decay, so I'm going to draw decay. Going down. Okay, now my final answer, I need to have a vertical flip, so I'm going to flip. Alright, so the blue one is my final. And it says, as we approach negative infinity. So I'm going to trace negative infinity to the left, minus going down. So negative infinity is going to be our answer. Alright, now for the next one, we're going to do the same exact thing. So start with pink because it's the original. And it says our horizontal asymptote is at negative 3. Okay, then we have what looks like a horizontal flip. Okay, and then E is 2.7, so it's growth. So originally it was growing, that looks like this. Good. And then we were supposed to flip it horizontally, so I'm just going to flip it over. Okay? Remember, it doesn't have to be perfect as long as you have general shape. So this asks about negative infinity, so that means to the left. My blue one is the final, so positive infinity will be my answer. Okay? Now, for the next one, we'll go through and label everything. So, this one is HA. This one says horizontal flip. Flip. This one is a vertical flip. And then this one means growth. So we have a lot of things going on here. Okay, great. So now I'm going to go through and I'm going to draw my axes in pink. Draw my horizontal asymptote. It says we're supposed to grow. Alright, so I grew. Now I need to pick another color because I have a lot of flips going on. So I'm actually going to do my horizontal flip first. I'll underline it in purple. My horizontal flip. Okay. And then I'm going to go through and I'm going to do, in blue, my final, my vertical flip. So my vertical flip looks like this. Okay? So now that's about towards positive infinity. So towards positive infinity, that's going to the right. It's getting closer to the asymptote, so negative 3. Alright? So for letter D, we're going to do the same thing. So all of our labeling. So we have our HA. We have DK. We have a vertical flip. And then we have a horizontal flip. Okay? And then I'm going to draw my axes again in pink because this is the original. It says +1 for my horizontal asymptote. Alright? And now my original says that it's DK. Alright? Now we need to go through. I need another color because I got 2 flips. So I'm going to do horizontal flip. And then it asked me to also do a vertical flip. Oh my gosh. A vertical flip. So, okay, vertical flip. Alright. So I took my purple one and I flipped it vertically. So, it asks us about positive infinity, so I'm going to trace to the right, and that looks like it's going down towards negative infinity. Alright? So you are going to have to get good at graphing these because it's going to be really important for you to be able to answer these questions. Now, I have had people that don't draw it but still get the answer right. I would encourage you to draw it no matter what. But if you get it right without drawing it, then you should be okay. Although Miss Wise might have a different opinion there. So you should really just draw it just in case. Okay? Now, for these ones, it looks like we still have the limits, but if you look, it doesn't look like we have infinities anymore. So when we go through and we don't have infinities, we can actually just plug it straight in and see what happens. If it gets 0 on the bottom, then we need to try again. We need to do something fancier. But if not, just go ahead and plug it in. So I'm going to show plugging in for E and F, and then I'll teach you or show you how to do G and H because I know those are a little bit more difficult. All right, so now I have the answers shown to these two. So I do want to tell you that when I write 1 minus E over E and 21 over 4, these need to be one fraction. Okay, it's just much nicer when they're exactly one fraction. So make your denominator the same and then combine them. Okay, so for letter G, we have the limit as theta approaches pi over 3 of cosine 2 theta over theta. So since theta is not 0, I can go through and just plug it in. Cosine of 2 times pi over 3 over pi over 3. So the cosine of 2 pi over 3, that's what that says, right? So the cosine of 2 pi over 3 is exactly negative 1/2 over pi over 3. So what you can do here is you can do keep, change, flip. You have negative 1/2. That's keeping that one. Change this to multiply. And then 3 pi over 2. Okay? So it gives you negative 3 pi over 4. Alright? Now I'll do the same exact thing here for H. So I can just plug it in. 3 pi over 2. And then I actually like to show it as squared afterwards. But you can show it either way as long as the answer is correct. So 3 times pi over 2, the y value is 1. So 3 times 1 squared is 3. Remember, square first, then multiply. Alright, now it says evaluate each limit first by rewriting the function using identity. So what we're going to do is basically try to simplify A, B, and C just by rewriting. Once we rewrite it, then we can just plug in. So I'm going to show you A and then see if you can simplify B and C. So for the first one, I'm going to keep the limit because I'm just making it look different. So if my thetas are still there, then I need my limit notation. And you're going to do 2 cosine theta. And then you should be able to tell me that cotangent theta is actually cosine theta over sine theta. And now we should go through and just put it together. So we have the limit as theta approaches pi over 2 of 2 cosine squared theta over sine theta. Now we can just go through and plug in because the sine of pi over 2 doesn't get a 0. So we can actually just plug in. So 2 cosine of pi over 2 and then square it afterwards over sine of pi over 2. Okay, so when we do that, we have 2, and then the cosine of pi over 2 is just the x value of pi over 2. So that's 0 squared over sine of pi over 2 is just the y value, so 1. So we just get a 0. Because we have 0 on top, 0 divided by 1 is 0. Okay? So now what I'm going to do is I'm going to pause it and see what you can do with letter B. Now hopefully we've rewritten it like this. One thing that you can do is you can put this over 1, and then you have sine theta and sine theta cancel each other out. You have the limit as theta approaches pi over 4 of 1 over 3 theta. So now all we need to do is just plug it in. So 1 over 3 pi over 4. So keep, change, flip actually gives us 4 over 3 pi. And that's all. You can actually go through and just remember that when you have 1 over a fraction, it just flips to a fraction. Okay? Alright, so now let's reorder the other one. Pause it and at this step right here, I'd like to go through and do keep, change, flip again. So I do limit as theta approaches pi over 4. And then I'm going to keep sine theta, cosine theta. And then I'm going to do change to multiply and then flip upside down. So cosine theta over sine theta. Now what's really nice is I can put this over 1 And then I can actually simplify the sign. So we have sine theta and sine theta. And then you just have the limit as theta approaches pi over 4 of cosine squared theta. Now we can just go through and plug it in. So we have the cosine of pi over 4, and then we need to square it. So that's going to be root 2 over 2, and then square it. So when you do root 2 over 2 and you square it, you get 2 over 4, which is just 1/2. Okay? Now we're going to go on to the next page. So what this is this should say, first of all, special, not specifical, so special trig limit. So what we're going to do is just try and locate these things. So it says sine theta over theta equals 1. That just means sine of something over that same something needs to get us 1, or will get us 1. It doesn't have to be just plain theta, but it has to match top and bottom. Okay? And it'll always get us 1. Now the other one we're going to be searching for when we're doing problems is 1 minus cosine theta over theta. That's going to get us 0. So what we need to do is we need to go through and make sure that they match. So for letter A says 3 sine 5 theta over 2 theta. So what I'm trying to match, it needs to match right here, 5 theta. I need that. What you'll notice is right now I don't have 5 theta on the bottom. So what I'm going to do is I'm actually going to write it like this. So I'm going to write the limit as theta approaches 0 of 3 over 2 times sine theta, 5 theta over theta. Now, you might be asking, why is this helpful? Because actually, still we have a problem here. We still don't have 5 theta. So what we need to do is on the top and the bottom, we need to multiply it by 5. Okay, because multiplying by 1 doesn't actually hurt anything. So what we have now is we actually have the limit as theta approaches 0. Now, one thing that you should notice is that up top here, this 5 isn't actually helping sine 5 theta, so we're going to actually just move it in front towards the 3. So it's going to go 3 times 5 sine 5 theta over, and then we need the 5 here. This needs to come together. That's what we were hoping for. So 5 theta, and then the 2 remains out here. So if you remember your properties allow you to take coefficients and move them to the front of your limit. So you can actually go like this. 3 times 5 over 2, the limit as theta approaches 0. And then you have sine 5 theta over 5 theta, which is what you needed. You needed those to match, and now they do. So as long as they match each other, you're going to get 1. It doesn't have to be just plain theta. So now we're going to have 3 times 5 over 2 times 1, which just gets us 15 over 2. Okay? Now, what we're going to do for the next one is we're actually going to have to be really fancy here because I see both the cosine property and I see the sine property. So what I want to tell you is when you have these two things added, remember we said that the limit as x approaches c of f of x plus c of x, you can actually separate those. So what we're going to do is we're going to try to separate them. So we're going to have the limit as theta approaches 0 of 1 minus cosine theta. Now, when you do this, you have to actually put a theta under it because it's 1 minus cosine over theta. And then when you separate it, you're going to write the limit as theta approaches 0 of sine 3 theta. But remember when you separate, you need to have a theta down here as well. Because remember, this is almost like back in Algebra 1 when you had something like this. X plus 7 over 2, and you wanted to graph it, you put x over 2 plus 7 over 2. Okay, so each of them have to have the denominator in order to be able to put them back together to make it look like the original. Okay, so now what we need to look at is do our properties match? So it says 1 minus cosine theta over theta is 0. But then on the right side, we have a problem because I don't have a 3 theta in the bottom. So what I need to do is multiply by 3, multiply by 3. Now we have everything looking good. 3 and theta, that's great. Sine 3 theta, and this 3 is extra, so we're going to actually move it right here. So I'm going to rewrite it one time just to make sure that I have everything in its place and it matches perfectly. So the limit as theta approaches 0 of 1 minus cosine theta over theta plus 3, because remember we don't need the top one, limit as theta approaches 0 of sine 3 theta over 3 theta. Now these match, so same something, top and bottom, that's what we needed. So this one is 0 plus 3 times, and then the sine one said that it got us 1. So that equals just 3. All right? So if you need help with these things, all you have to do is come in and see us, but that's all you need to know about doing these special properties here. So just memorize those and always search for them when you're doing limits.